So far, we have been talking about operations as far as a single database table is concerned. But of course, in real-world applications, there are several database tables we have to manipulate, and of course, these database tables are not independent of each other. So in the coming lectures, we are going to talk about how to define the relationships between multiple tables. So first of all, let's talk about what is a foreign key. A foreign key is a column or multiple columns in a table that links to a column or multiple columns in another table. So basically, we can connect two tables with the help of foreign keys. Okay, a table may have multiple foreign keys, and every single foreign key references to a primary key of the different parent tables. So what does it mean exactly? For example, we have a person database table with 4 columns: ID, name, age, and university, and we have a university database table with a given ID and a name. For example, we have MIT as the first university, and we have Harvard as the second university, and we have several persons: Kevin, Joe, Anna, Adam. As you can see, the university column of the person database table can store a reference to a university in another database table. In this case, we are dealing with the university database table. So the university column stores a so-called foreign key, and this is the child table or the referencing table. These values are referencing the given universities in another database table. So this is the child table, and the university is the parent table or the reference table. Okay, and as you can see, the university has the primary key in this case. So the university database has 2 columns, the ID and the name. And the ID, so basically the primary key of the university database table, can be present in another database table, and this is what we call foreign key. So as far as the person database table's university column is concerned, these values are referencing the universities. So these values are called the foreign keys, and the ID values are the primary keys. Okay, and of course these values are not independent of each other. So the university with ID 1 as a foreign key is referencing the primary key in the university database table. So basically, this is how we can connect 2 databases with the help of foreign keys. Okay, so this is what we are going to implement in the next lecture, and then we are going to talk about another problem as far as database tables are concerned. Thanks for watching. In the previous lecture, we have been talking about the theoretical background of foreign keys, and in this lecture we are going to connect 2 independent database tables. So first of all, let's create a database table, the so-called university. Of course, what do we have to do? We are going to have a university ID that's going to be an integer primary key, and for example, we have the auto increment feature. So we have something like this, and of course we have a university name that's going to be a varchar 30. And for example, this name cannot be null. So if we use something like this, of course it is working fine. So what does it mean? We can describe the university database table, and if we use something like this, of course we have the university ID that is the primary key, and it has the auto increment feature, and we have a university name that is a variable length string. Okay, so first of all, let's insert into this table. So insert into university the values. We have to define the university name here, and what's going to be the values? First of all, we insert MIT, and then we insert, for example, Harvard. Okay, so something like this. So if we run the query, then of course it is working fine. So we can select everything from the university database table, and of course there's going to be 2 entries: MIT with university ID 1 and Harvard with university ID 2. Okay, so far so good. Let's create the database table for the student. So create the table for the student, and what do we have to do? Of course we have a student ID that's going to be an integer, a primary key with the auto increment feature. We have a student name, so student name is equals to a variable length character, so string basically 30. Okay. For example, it cannot be null. We have a person age, so we have the age, it is going to be a tiny int and cannot be null. And we have the university, that's going to be an integer, and after that we can define the so-called constraints. So we would like to make sure that the foreign key is going to be the university. So this is the database table column that's going to be a foreign key, and of course it is going to reference the university database table related university ID. So we have references the university database table as far as the university ID is concerned. So we have to use something like this, and let's see whether it is working fine or not. Okay, so if we save and run the query, then as you can see it is working fine. So if we describe the student database table, then of course there's going to be several fields. The student ID, that is the primary key, and it has the auto increment feature. We have the student name, we have an age, and we have a university that is going to be a foreign key. It stands for multiple key because of course a single table may contain multiple foreign keys. This is what we have been talking about in the previous lectures. Okay, so we have to insert into the student database table as far as the student name, as far as the age, and as far as the university is concerned. What about the values? For example, we have Kevin with age 19, and for example, the foreign key is a null because Kevin is not attending a given university. We have Adam with age 22, and it has the MIT, so university ID 1. Then we have, for example, Anna with 23 as the age and attending Harvard. So if we use something like this, then I guess it is going to work just fine, yeah? So if we select everything from the student database table, then of course we have the student IDs 1, 2, 3, student name Kevin, Adam, and Anna, age 19, 22, and 23, and as you can see we have the foreign keys exactly as we have discussed in the theoretical section. Null value 1 and 2. It is working fine. This is exactly how foreign keys work, because this university value 1 is going to reference the primary key in the university table. The primary key 1 is the university MIT. As far as Anna is concerned, it has the university value 2. What does it mean? If we select everything from the university, then we can check that value 2 as the primary key in the university ID has something to do with Harvard. And this is exactly what we have been discussing in the theoretical section, that the foreign key in a given table is a primary key in another database table, and this is exactly what's happening here. This is the primary key in the university table. Okay, so this is how we can connect database tables, and in the coming lectures we are going to talk about what if we would like to change the value in the parent table. So for example, if we want to change the university ID from 1 to 10, then of course this change must be reflected in the child table as far as the students are concerned. And this is exactly what we are going to talk about. Thanks for watching. In the previous lectures, we have already discussed how to deal with multiple tables with the help of a foreign key. So for example, in this example, the person table university column is storing foreign keys that are primary keys in another database table, in this case, the university table. So this is how we can connect two database tables. But of course, a good question is what happens to the foreign keys when the given table's values are updated or removed? And of course, there are several algorithms to deal with this problem. So the problem is that, for example, we have the university with ID 1 name MIT, ID 2 name Harvard, and what if we, for example, remove the university with ID 1 and name MIT? Of course, in the person database table, we are referencing the MIT university. So a good question is what's going to happen with the foreign keys as far as the reference referencing or the child table is concerned. And of course, there are several solutions. The first solution is the so-called restrict method. This is the simplest solution. It is forbidden to update or remove a given row, so basically we cannot modify the value in the parent database table. So if a row from a parent table has a matching row in the child table, then MySQL rejects updating or removing rows in the parent table. So as far as the restrict approach is concerned, when we want to remove, for example, the MIT with ID 1 from the university database table, then MySQL is going to take a look at the person database table and it will come to the conclusion that it is not possible to remove MIT because the person database table is referencing that given row. So what's going to happen? MySQL is not going to remove that given row, which means that we are not able to remove MIT because there are foreign keys in other database tables referencing that given entity. So this is the first approach, basically the simplest solution, that we do not allow the database table to change. Of course, there are other approaches. For example, we can set the values to be null. So this is another solution how to deal with the problem. Whenever the entry in the parent table is removed or updated, then the matching values are set to be nulls. So if a row from a parent table has a matching row in the child table, then MySQL sets the value to be a null. So what does it mean exactly? If we have the same database tables, the person and the university, and we remove MIT, as you can see, then of course there's going to be an issue because in the person database table, we are referencing a given primary key that's not present in the university database table. So what's going to happen? MySQL is going to update these values to be null values. So this is how we can solve this problem. Then of course we have the most complicated approach, the so-called cascade approach, which means that whenever the entry in the parent table is removed or updated, then the matching values are updated as well. So if a row from a parent table is deleted or updated, then the values of the matching rows in the child table automatically removed or updated. So what does it mean exactly? If we have database tables and we update, for example, the university with name MIT as far as the ID is concerned, and we update this value to be 10, then of course again it is not going to work fine because in the person database table we are referencing a primary key in the university database table that's not present anymore. So what do we have to do? Because of the cascading approach, MySQL is going to update the foreign keys in the person database table as well. So this is how we can propagate changes in the parent table to the child table, and we will update the values accordingly. Of course, we have to be very careful with cascading because, for example, if we have the same situation and we remove the MIT with ID 1 from the university database table, then what's going to happen with the person table? Of course, MySQL is going to remove the entries from the person database table where the university ID is equals to 1. So this is what's going to happen. And of course, usually we would like to avoid removing entries from a database table. So sometimes cascading is working extremely fine, and sometimes the set null approach is going to be the perfect solution. So this is what we are going to talk about in the coming lectures. Thanks for watching. In the previous lectures, we have created two database tables, the university and the student, and we have used foreign keys. So basically, we connected the two database tables. And the good question is what's going to happen if we try to update the university ID that's already present in the university table? Of course, it is a problem because this university ID is referenced by other entities in another database table, in this case, the student database table, as a foreign key. So let's update the university database table and let's set the university ID to be 10 where the university ID is equals to 1. So basically we are going to manipulate the first row of the university database table, as you can see, with ID 1 and name MIT, and we are going to change the university ID from 1 to 10. And of course, let's see what's going to happen. If we try to execute, then of course there's going to be an error, as you can see, cannot delete or update a parent row because of the foreign key constraint. So this is what we have been talking about, that this is the restrict case. So basically MySQL rejects updating or removing rows in the parent table. And this is why we are going to talk about cascading. First of all, let's try to drop the university. Of course, MySQL is not going to let us drop the university table because other database tables are depending on that given table. So if we use something like this, cannot drop table university referenced by a foreign key constraint. So first of all, we have to drop the student, and then we have to drop the university. So drop table and university. Or maybe, sorry for that, I am not going to drop the university because the university is going to be just fine. So if we select star from university, then of course we need a university database table, and I guess it is going to be just fine. We have the university ID and the university name with MIT and Harvard. Okay, it's going to be just fine. Let's create a table for the students. So we have something like this. We have an ID that's an integer, primary key with the auto increment feature. We have a student name that's going to be a varchar as usual with 30 as the value, and we have the university that's going to be a foreign key. So we have a university that's going to be an integer, and we can create a constraint. We can give name to a constraint. So for example, this is the constraint, and we create a foreign key as far as the university column is concerned. So this university column is going to be the foreign key. Of course, we have to references, so references the university as far as the university ID is concerned. So this is exactly what we have been talking about in the previous lectures as well, that the university is the column in the student database table, and it references the university database table and the university ID. This is the university ID, the primary key in the university database table. And we can define on update, we can define the cascading, and on delete we can define cascading. So this is what we have to do. So basically, with the help of these lines of codes, we tell MySQL that okay, the university is going to be a foreign key. It's going to reference the university ID in the university database table, and whenever we update or delete a given entity from the university, then let's update the university in this table. So basically we would like to use cascading. So if we execute this query, then it is going to work fine. Sorry for that, there's a bug in my version of MySQL Workbench because it has the tendency not to execute the given operation, but if I rerun the same query, then it is going to execute it without any issue. Okay, so we have created a foreign key with cascading. So what does it mean? First of all, let's create some students. So I would like to insert into student as far as the student name and as far as the university is concerned. So what about the values? Values will be Adam with 19 as the age and null, so Adam is not attending a given university. Okay, then we have, for example, Anna with age 23 and it is attending MIT. Then we have, for example, Kevin, he's 25 and he's attending Harvard. And for example, we have Daniel, he's 24 and he's attending MIT as well. So if we use something like this, oh, sorry for that, because I guess now there are no age parameters. Sorry for that, my bad. There's no age parameter. Okay, so if we rerun the query, then it is working fine. So if we select everything from the student database table, then let's see what's going to be the result. Of course, we have Adam, Anna, Kevin, and Daniel, and the universities are 1 and 2. So these are the foreign keys referencing the universities in the university database table. So let's see what's going to happen with the student table related university column if we change the primary keys in the university table. So let's update the university and let's set the university ID to be equals to 10, where the university ID is equals to 1. So if we use something like this, and because we are using cascading, let's see what's going to happen. We are able to execute this given query. So if we select everything from the university database table, then what's going to happen? We have the university ID is equals to 10 as far as MIT is concerned, and let's try to select everything from the student database table. And we can come to the conclusion that, as you can see, because of cascading, the university column related values have changed. So far, MIT has been represented with integer value 1, but because we have updated the university table related primary keys to be 10, this is why the student table have been updated as well. So this is exactly what we have been talking about in a theoretical section. If we update the MIT primary key to be 10, then MySQL is going to update the student table. Okay, in this case, we are dealing with the person database table. Sorry for that. In our concrete implementation, we use the student database table. But anyways, what's crucial that MySQL is going to update the university column accordingly because we are using cascading. So this is why it is absolutely crucial to define the relationship between two tables, and with the help of cascading, we can define what's going to happen whenever we update the parent database table. Of course, we can make sure that these changes are going to be reflected in the child database tables as well. Thanks for watching.